Okay, so last class we talked about volumes in our lungs. Today we're just going to look at how we kind of record those, and then we'll look at gas exchange between our lungs and then between our body. So if you look here, we have two what we call spirometers. The one on the right is that you could usually look at the force of someone's breathing, but what we see most of the time in hospitals is something that looks like this. So someone that just had surgery or is having issues with their lungs or respiratory system, they're asked to blow out at a consistent force to meet some type of level, and it usually has like a little ball that floats up in here, and that's to just build up your respiratory system, build up your lung strength. So we would use a spirometer for a couple different reasons, but most of the time it's seen inside of hospitals, usually after a surgery or something along those lines. So you've probably gone to the doctors, especially during the winter time. If you're sick, they listen to your lungs with what we call a stethoscope over here. And they can hear a lot of things in there. They'll look for two sounds. One's called a bronchial sound, the other one is vesicular. Bronchial sounds come in your trachea and in your main branches of your bronchi. And what they're really looking for or listening for is like a crackling sound or showing that there's inflammation, meaning air is not passing through nice and easily. Sometimes with asthma, you'll hear people with wheezing. That again is showing that there's somewhat of a blockage or inflammation in your bronchi, which is causing that sound. We also have what are called vesicular sounds, and those are out further. So you'll see them out here, and that they're actually listening to more the inside of your lungs, meaning your alveoli. So people with emphysema, which is really a swelling of that alveoli, they're listening in there to hear if they if there's a crackling or there's like a whistling sound almost. It should be nice and quiet, but when people are sick, they have inflammation in there, and then they'll get a lot louder sounds when people take deep breaths in and out. So you'll feel the doctor, put the stethoscope in a couple different areas, somewhere here, and sometimes they'll do it right along the sides because they're really looking to listen to all the different parts of your lungs. When we look at that air that you bring in, what we have to remember is this is air from the outside here, okay, and this is obviously your blood coming through. It comes in from your heart, and it's going to go back to your heart and then be pumped out to the rest of your body. What we want to focus on is one, notice how thin those layers are. It's like two thin walls that it has to get through. You have your simple squamous on your alveoli sacs, and then you have really your single layer on your blood vessels as well. Okay, what I want you to focus on is these numbers right here. Okay, now remember, this is the air over here. Okay, so your air that you breathe in is going to have 100, we'll say, a pressure of 100 molecules of oxygen, and the air that's coming from your body only has about 40. Now remember, we're going from high to low, so the oxygen is going to go from 100 towards your 40, and then your CO2 is 45, so that's going to move towards the inside of your alveoli, which is only 40, and then when you exhale, that will leave your body, right? And then as that blood starts to go back towards your heart to then be pumped around your body, you have your oxygen being recouped from 40 to 100 and your CO2 back down to 40. You can notice how different the numbers become. CO2 isn't in a very, very high concentration, but we do want to bring in a ton of oxygen because that's used quite regularly by all of your cells. Okay, so once again, just remember, you have air coming in, you have your exchange happening, and then air is going to be going back out. Okay, if we look at gas exchange with our actual cells and our muscles, here's our blood. These are our cells, or we could call it tissue as well. That's pretty ugly, but sorry. CO2 is going to want to be put back into the bloodstream because that has to make its way back to the lungs. And we're going to be putting oxygen from that blood into that tissue. So O2 is going to go into your tissue, CO2 is going to come out. And CO2 is carried in your blood mostly in the form of bicarbonate. Bicarbonate is a base, and that makes your blood right around 7.35. Whoops. And that's the pH. So your pH is around 7.35 all the time, and we want it there. Your body constantly regulates the pH of that blood. So you're giving off oxygen into your tissue. CO2 is being released, and it's going to be converted into bicarbonate. There is going to be some carbonic acid, and that carbonic acid, as you see here, you're going to have carbonic acid and bicarbonate kind of playing this balancing game, and your body's going to constantly balance that so your blood plasma stays at around 7.35. Not to miss, but oxygen is carried on hemoglobin. We should know that using iron. People that are anemic, sometimes they have an iron deficiency in which they can't carry enough oxygen around their body, so they get tired easier, headaches, and that kind of stuff. Okay, here's just an overall look. Once again, I just want you to focus on the movement of oxygen and CO2. Okay, that would be inside the alveoli over here. And then you're doing pretty much the opposite on your body cells to put that oxygen into your tissues and then remove that CO2 and get that filtered out in your lungs so you can breathe that out. Two more things to really look at when we talk about gas exchange. We have what's called hypoxia, which can happen if someone's being choked or you're in a position where you can't breathe in enough oxygen for whatever you're doing or just to survive. And then you also have what's called carbon monoxide poisoning. Okay, carbon monoxide poisoning is deadly, and they call it the silent killer. It's not really silent, it's odorless. It's the odorless killer. And the reason for that is carbon monoxide is released from natural gas furnaces or even oil furnaces. If they're malfunctioning, they release unburned carbon monoxide. It should be burned and released up the chimney, but sometimes things go wrong, so it's released into your house. And if you're sleeping, you can't sense it. You're in a deep sleep and your body gets overwhelmed. And the reason for that is because oxygen is supposed to latch onto red blood cells. But what happens is if carbon monoxide is present, they take the place of those oxygen and they don't release very easily. So the carbon monoxide will stay attached for long periods of time, not allowing oxygen to be attached, and people wind up getting dizzy, or if it's in your sleep, or if you don't realize what's happening, even if you are awake, you can actually die from it because you need oxygen to transport around your body, get to your brain, and obviously be able to do all the functions that are necessary. So it's very, very serious, and it's the reason why people have carbon monoxide detectors in their house for something like that. The last thing is what we call hyperventilation and hypoventilation. So you've probably heard of hyperventilation, which is the more commonly heard term, and you've seen it probably happen on videos or possibly someone on an airplane or something like that. So what happens with hyperventilation is something occurs that causes your blood pH to change, whether it's nervousness and people start breathing a lot. If you start breathing a lot, you start releasing a lot of CO2. And like I was saying before, your body's constantly doing a balance between carbonic acid and bicarbonate, these two down here. We're not going to get into the whole chemistry behind it, but if you're breathing out a lot of carbon dioxide, meaning very, very rapidly, very quickly, it's going to cause more bicarbonate to be present. Because if you look right here, carbonic acid gets turned into CO2, which you then release. So if you're breathing a lot of CO2 out very fast, you're going to be switching carbonic acid into CO2 very quickly, which means that carbonic acid is an acid, so your pH is actually going to rise. So one way to fix that, if you see my little man over here, is to breathe into a bag, because you're going to release a lot of CO2. So you're going to actually breathe that right back in, and you're going to allow your body to produce more carbonic acid. So then that brings your blood pH back closer to 7.35, and you start to feel a lot better, and you got to try to calm yourself down. On the opposite side of that, you have what's called hypoventilation. That is where, for whatever reason, it could be that you're breathing a lot slower. Maybe something occurred where everything has been slowed down quite significantly. It can cause your CO2 to rise. And like we said over here, if your CO2 rises, that means you're going to produce more carbonic acid, which means your pH is going to become more acidic. So you go from 7.35, maybe closer to 7.3. 7.25 is getting very, very dangerous. So it doesn't take much to change your blood pH, and your body's constantly trying to regulate that. I hope all this helps, and please feel free to reach out with any questions.